In this lecture, we'll learn how to apply the F-test to compare the standard deviations from two different data sets. In order to determine if the mean values x bar sub 1 and x bar sub 2 from two sets of data are statistically different from one another, we first have to compare the standard deviations, s sub 1 and s sub 2, to each other to see if they're statistically different from one another. We do this by taking the ratio of the two variances from each data set. In other words, we select the larger of the two standard deviations, square it, then compare it to the square of the standard deviation from the other data set. Once we have this ratio, which is defined as f-calc, we can compare the value of f-calc to the value of f-table after we subtract 1 degree of freedom for our calculation. When comparing a calculated statistic to one in a data table, it's typical to see that we will consider a difference to be significant when the calculated value is greater than the tabulated value. Let's step through an example to demonstrate what I mean. Suppose that we have two instruments running the same type of analysis. We want to compare the mean of the first instrument with a standard deviation of 0.55 for 6 measurements to another instrument that has a standard deviation of 0.35 for 10 measurements. We have to compare the standard deviations first to decide if we can actually compare the means to each other. We see the original instrument has a lower standard deviation, but we don't necessarily know why. It could be that increasing the number of measurements decreased the standard deviation, or the original instrument may be better calibrated or tuned. Regardless, let's calculate F. We see that f-calc is 2.469. Don't worry about the number of significant figures here. Just make sure that you're taking as many as you need to match the data presented in the table. Next, we need to find the correct value of f-table. Here we see that our first data set had n equals 6 measurements. That gives us n minus 1 equals 5 degrees of freedom across the top. Our second data set had n equal 10 measurements for 9 degrees of freedom down the side. Where the row and column intersect, we find our value for f-table. In comparing the calculated and tabulated values of f, we see that f-calc is less than f-table. This means that the difference between the standard deviations is not significant, so we can go on to compare the means of the two data sets, which we'll do in the next lecture.